Okay, so monohybrid crossing. Monohybrid means you only have one characteristics. And now I will show you this one. This is a typical one, and this is just a general, all right? It can be anything. For this one, it can be heterozygous, homozygous, it can be anything. But in this, you can see that the purple is a dominant one and the white is the recessive one. And you can see that both of these are homozygous. So homozygous dominant, homozygous recessive. That is what I want to say. The very first generation, it is homozygous. It can either be dominant or the recessive. And now, after we, cross it, we cross this one with this one, and we got this. So this is the offspring of these two. So what you get is the heterozygous. All right, and this result is called the F1 generation. And then we are going to use this one, F1 generation. We are going to cross F1 generation with each other. All right, so this is how you can see it. Okay, maybe I will write it down. Oh, I think I have already written something. Right, I will show you. Wait, give me some minutes. Where is the monohybrid? This one. So here is the same, all right? Purple and white, homozygous dominant, homozygous recessive. And because it's homo, you only take one allele. And for this is homozygous recessive, so you only take one allele and you multiply it. So what you get is the heterozygous, and this is first generation. And now we are going to cross it. We are going to use first generation to produce the second generation. So this is first generation. First generation is small b and big b, right? That is heterozygous dominant. You can either say heterozygous dominant or heterozygous recessive. Anything is the same. The genotype is the same. So here, big b and small b, big b and small b. This one is F1 generation. This one is F1 generation as well. So here, because we have heterozygous, what happened is we have to write two different alleles for this. Big B, small b. For this one as well, big B, small b. And now you're going to multiply it. So what you get is big B, big B, big B, small b, big B, small b, small b. So this is the result. And now you got these genotypes. But this is homozygous dominant. This is heterozygous dominant. This is heterozygous dominant. It is true that you have a recessive alleles, but dominance will always surpass the recessive. So the phenotype is the same for these three genotypes. So you got 3 purple and 1 white, and that is got 3:1 ratio. That is what I want. Like, you should explain it like this. If you really understand, please try to explain dihybrid for me. Dihybrid for me. All right. For dihybrid, I think I didn't write like that. Okay. So that is what I mean. Everything is homozygous for the very first generation, or you can say grandparent generation. Okay, this one is grandparent generation. This one is son and daughter generation, the same as first generation. And this is the grandparent generation. All right, grandparents, son and daughter, and grandparent. Okay, so anyway, here the very first generation would be homozygous dominant and homozygous recessive. So the final result is just this one, the first generation, this one. And now you're going to cross first generation with each other. So how you write this? TF. Do you see how I write this? This one T and F. This one T, big P and small f. So, and then small t and big f, small t and small f. So here, the way you write for dihybrid is a little bit different from monohybrid because you have two characteristics. Now when you write it, you have two different alleles, and now this one is going to cross with 4 different types, and you will have a very big table here. Altogether, you will have 16 genotypes, and for phenotypes, you will have 9:3:1 ratio. So please show me that walking.